Imagine a world where a full-sized house can be printed in just days, costing a fraction of traditional builds. By 2030, could 3D printing truly be the answer to our global housing crisis, offering affordable homes to millions? We're diving deep into the technology, the breakthroughs, and the very real challenges that stand between us and a future of truly accessible shelter. Right now, the housing market in many parts of the world feels broken. Prices are soaring, supply can't keep up with demand, and the dream of owning a home is slipping away for countless people. But what if we could fundamentally change how we build? What if we could automate the process, slash costs, and erect houses in record time? This isn't science fiction. It's the promise of 3D printed construction. The basic idea is pretty incredible. A massive gantry-style robot, armed with a nozzle, moves along a predetermined path, extruding a special concrete-like material layer by layer. Think of a giant cake decorator, but instead of icing, it's building the walls of a house. This process, also known as additive manufacturing, has been around for a while, but it's only recently that it's been scaled up for construction. Companies like ICON, Apis Core, and Mighty Buildings are leading the charge. We've seen some truly impressive feats. In Texas, a community of 3D printed homes sold out quickly. In Dubai, the world's largest 3D printed two-story building stands as a testament to the technology's potential. These aren't just tiny experimental sheds anymore. These are real, livable homes with plumbing, electricity, and all the modern comforts. So, how does this actually solve the affordability problem? The answer lies in three key areas: speed, labor, and materials. First, speed. A traditional home can take months, sometimes even a year to build. A 3D printer can lay down the entire wall system for a small home in as little as 24 to 48 hours. This dramatically reduces construction timelines, which in turn cuts down on labor costs and the financing costs associated with a long project. Getting families into homes faster is a huge win. Second, labor. The construction industry is facing a severe labor shortage. It's hard physical work, and there aren't enough skilled tradespeople to meet demand. 3D printing automates one of the most labor-intensive parts of building, the framing and wall construction. A small crew of 3 or 4 people can oversee the printing process, compared to a much larger team needed for traditional methods. This doesn't mean robots are taking all the jobs. It just shifts the type of work required. We'll still need electricians, plumbers, roofers, and finishers. But by automating the structure, we can build more with the workforce we have. And third, materials. 3D printing can be incredibly efficient with materials. The printer places the concrete mixture exactly where it's needed, minimizing waste. Traditional construction can produce tons of waste from wood cut-offs, broken drywall, and excess concrete. Less waste means lower material costs and a smaller environmental footprint. Plus, innovators are developing new, more sustainable printing materials, incorporating recycled components and creating formulas with a lower carbon footprint than standard concrete. This all sounds amazing, right? A utopian future of fast, cheap, sustainable housing for everyone. So why aren't we seeing 3D printed houses on every street corner? Well, the road from a promising prototype to a global solution is paved with some serious challenges. Let's start with the technology itself. The giant printers are expensive pieces of equipment. For a construction company to invest in one, they need a steady pipeline of projects to make it financially viable. That's a big upfront cost that smaller builders just can't afford. Then there's the material science. The ink for these printers isn't just regular concrete. It's a proprietary mix, often called lavacrete or something similar, that has to be precisely engineered. It needs to flow smoothly through the nozzle, be strong enough to support the layers above it almost immediately, and cure properly to create a durable structure. Developing and perfecting these materials is a complex and ongoing process. The weather also plays a huge role. Printing in the rain, extreme heat, or freezing cold can seriously affect how the material sets, creating potential weak points in the structure. And perhaps the biggest hurdle of all is regulation. Building codes are the rulebook for construction, ensuring that homes are safe and will last for generations. These codes were written for wood frames, concrete blocks, and steel beams. They weren't written for walls extruded by a robot. Getting a new construction method approved is a slow, painstaking process. Each city, county, and state has its own set of rules. A 3D printed house approved in Austin, Texas, might not be permissible in Miami, Florida, where it needs to withstand hurricane-force winds. Engineers and builders have to conduct extensive testing to prove that these new structures meet or exceed existing safety standards for things like structural integrity, fire resistance, and earthquake resilience. This regulatory patchwork is a major bottleneck slowing down widespread adoption. We also have to think about the rest of the house. The printer only builds the walls. You still need to install the foundation, the roof, the windows, the doors, the electrical wiring, and the plumbing. Integrating these traditional trades with the new 3D printed shell requires new workflows and skilled coordination. How do you run wires and pipes through a solid printed wall? Some designs incorporate conduits directly into the printed layers, while others require different solutions. It's a logistical puzzle that the industry is still figuring out. Finally, there's public perception. Would you feel comfortable living in a house printed by a robot? For many, the idea is still a novelty. There's a natural hesitation about something so new and different. We're used to homes built with familiar materials and methods. Overcoming this psychological barrier and proving the long-term durability and safety of these homes is crucial for building consumer trust. People need to see these homes not as strange experiments, but as safe, comfortable, and desirable places to live. So let's circle back to our original question: can 3D printed buildings revolutionize affordable housing by 2030? Revolutionize is a strong word. It implies a complete and radical change. By 2030, it's unlikely that 3D printing will have completely replaced traditional construction. The regulatory hurdles and the need for more infrastructure and skilled operators are too significant to overcome globally in just a few years. However, it absolutely has the potential to be a powerful disruptive force in the affordable housing sector. Where it will likely make the biggest impact first is in specific, targeted applications. Think disaster relief, where the ability to quickly print basic, durable shelters after a hurricane or earthquake could be life-saving. Think of building communities in remote areas where transporting traditional materials and labor is prohibitively expensive. We'll also see it become a key solution for building specific types of housing, like starter homes, accessory dwelling units, or social housing projects. In these cases, the ability to replicate a standardized design quickly and cheaply is a massive advantage. Imagine a city partnering with a 3D printing company to build a whole neighborhood of affordable starter homes, slashing the construction time and cost for the project. That's not a far-off dream. That is happening right now. For 3D printing to truly scale by 2030, we need a few things to happen. We need continued innovation in material science to create cheaper, stronger, and more sustainable printing mixtures. We need a concerted effort from builders and regulators to work together to create standardized codes and testing protocols for 3D printed structures. And we need more investment in training a new workforce that can operate this technology and integrate it with traditional trades. The path forward is incremental. It's about solving one problem at a time. Each successful project, each new building code approval, and each happy homeowner builds momentum. 3D printing is not a magic bullet that will instantly solve the global housing crisis. But it is one of the most promising tools we have in our toolbox. It represents a fundamental shift in our thinking about how we build, moving from a labor-intensive, wasteful process to one that is automated, efficient, and potentially far more accessible. The year 2030 is just around the corner. While we may not all be living in 3D printed houses by then, the groundwork being laid today is setting the stage for a future where that might be a real possibility for our children. It's a future where a safe, affordable home is not a luxury, but a reality for millions more people around the world. The promise is real, the challenges are significant, but the potential is too great to ignore. Thanks so much for watching. What do you think? Is 3D printed housing the future or just a niche fad? Let us know in the comments below. And if you enjoyed this deep dive, don't forget to like this video and subscribe to our channel for more explorations into the technology shaping our world. See you next time.